My name is Mounir, and I'm a air traffic controller with Canada in Montreal. And today I will present to you this exploratory data analysis project that based on a data set that I downloaded from Transport Canada website that the Federal Department of Transportation in Canada. It has records from over 80 years of data of all the incidents and accidents that happen in the Canadian aviation, and they're described using the more than 500 columns. So that's a very large data set. I selected some of these columns in order to do my EDA project. A choice for this data set was really motivated by my passion for aviation and also my expertise in air traffic control. I've been with my company for the last 8 years. And usually I fill the reports if there's anything wrong. Actually, it's something that is not regular, which is an occurrence in aviation, so incident or accident. But I was curious to see what can we do with all this data once we have a huge amount of records that to use them and in order to improve safety, basically. And I selected for you today for my presentation some graphs. So the first one I want to share with you is the number of mortal injuries or death reported each year in Canadian aviation. So the question was simple: how many people are dying of accidents involving aviation in Canada each year? And so this is the resulting graph. The good news is that it is decreasing. The number is decreasing. So safety is being improved at some point, and we can see clearly the downward tendency. The thing I was curious about is those three peaks here. And obviously they were related to some high death count events, but I was wondering which counts, which events involve this. And that was actually, I was able to find them using Pandas, all the search tools. We have Pandas, which is really great software to explore all these CSV databases. And these are the top 10 worst accidents in Canadian history. And then among those three, I isolated the three worst accidents with their descriptions. And it is actually pretty clear that the number of deaths was pretty high here. And that was the reason why we have those three peaks. But the thing I wanted to share with you, actually, interesting insight actually, is that just 3 events out of 45,000 can affect the whole data set statistics. And they can, because those are outliers, and they affect the quality of our data. Let's see, for instance, if we plot the monthly average death counts breakdown or the whole data set, we still see peaks in July, September, and December. And our accident, actually, these 3 accidents happened in July, September, and December. So it's not more likely to die in an accident in Canada or if you fly on September. It's just that the number is really biased because of these accidents. We have to be really careful and really deal with the outliers before doing any regression or any data analysis work. Just be sure that our decisions or our models are not based on some unique event or unique data points. The second plot I want to show you is this one. This is actually this is based on the age of aircrafts, because my question was, because in Canada actually, or in the US, you can buy an aircraft for the price of a new car, a luxury car, but you can actually have it. Doesn't mean that you can afford it actually, because it's extremely expensive to own an aircraft due to maintenance, which is expensive, airworthiness, fees, etc. My question was, are those fees or those procedures, complicated procedures, helping the safety? And the answer actually is yes, surprisingly, because they're less older aircraft to deal with. So basically they cause less accidents. That's a point. But there is obviously a good effect of those procedures we are implementing on safety, because the aircraft, even old aircraft, are maintaining the same standards for safety as new aircraft. And that shows on the plot, we do not see a relationship or any correlation between the age of aircraft and the possibility of having an incident or having an accident. And the last point I wanted to detail here was the flight plan data importance in the safety. Part of my daily job is keeping up-to-date flight plans, putting the change on them if the pilot changed the route or destination or anything. And the flight plans actually are data that the forms that the pilot has to fill in before flying. This data includes contact informations, the route, and the search and rescue times, and equipment on board, survival equipment, instruments, a lot of information. And my question was, is this helping safety? And the answer is yes, actually, because as you can see on the plot here in the histogram, there are more likely to have three times fatal injuries or death count actually in the flights without flight plan or using flight note being just information that a pilot shares with his own company or family or friends, but not with the NAV Canada. So we are responsible for search and rescue in Canada. And as you can see, even most of the flights are using flight plans. They have less fatal injuries count. So flight plans are extremely important in search and rescue. The main reason is that they concentrate information in just one place. So it's really easy and quick to access information and to start search and rescue as soon as possible if an aircraft is missing. And that can change everything. There is a plot in the notebook that you can see that you could consult later, which shows that the death counts is really depending on the evacuation time, and difference between 5 minutes and 10 minutes can double the number of deaths just in the search and rescue operation. So it's extremely important to have as much data and to have quick access to it. And that's it. Actually, this is my selection of plots I wanted to share with you today. You can check the rest on the notebook, and I will finish by talking about what I'm planning in the future. First, I'll have to export the whole data set. This is pretty big one, and I'll be using the PEAT model, which is person, environment, task, and equipment model in order to do the risk analysis. This is the model we use in my company and in a lot of companies involved in risk management. I'll be also very interested to find a similar data set for other countries. So if we can do that, we could compare the difference between the policies, the procedures between countries, and see what can be done in order to improve global safety of flights in the world. Thank you for your attention, and I hope you will enjoy reading my blog post. If any questions, you can contact me via the Jovian website. Thank you.